Hello my dear, welcome to IMS GATE Academy. I hope you are all good and your preparation going to be in a right direction. My name is Pragyabrat Tripathi, okay, Faculty Department of Mechanical Engineering. See beta, study classes, previous classes will end up here. That means we have a quantitative parameter of what is that? We can measure the quantitative parameter of a process. That means extent of irreversibility is like this one, integration of dq by t. That means this tells about the quantitative parameter, okay, no problem at all. Now and we also take a look that what is the mean by this equality. That means equality, for the equality, that means this equality will hold during the reversible process when they are very close, and this in the irreversible process this equality is hold for the extreme of irreversibility. Hi Pratik, hi. This equality hold for the irreversibility. So during these two cases, during these cases, we can observe easily that the cyclic integration of dq by t is a very important parameter which can measure the extent of irreversibility. The extent of irreversibility. So we can say that here, what we can say that beta, we can say that from here we can say that next. That means, see, for any cycle, one second, for any cycle, for any cycle, for any type of cycle, for any type of cycle, that means either reversible or irreversible, okay, the cyclic integration of dq by t is less than equal to 0, okay, less than equal to 0, less than equal to 0. Now my dear, that means what we can say that for the reversible cycle, this is very important. From here, this is very important. That means for a reversible cycle, either power producing or power absorbing, that means this quantity, this parameter, which parameter dq by t is measured, is very much give the information about Okay, this is very much gives the information about the process. Okay, that means for the reversible process, not process beta, cycle. Okay, this is little bit mistake here. It is not process, it is a cycle. For the reversible cycle, what we can say that cyclic integration of dq by t is equal to 0. And for irreversible cycle, we can say that cyclic integration of dq by t is less than. See my dear, this is very important observation is what that this is the absolute value, no problem. That means this quantity gives the absolute value which is 0 in the cycle. That means when the device operating in a reversible manner, this quantity heat transfer divided by the temperature of the system boundary is summation of all is 0 if the cycle is reversible. That means you can think like that, beta. See, if this is your system, let's suppose, if this is your system, okay, if this is your system, okay, in this system, let's suppose here, in this is your boundary, different, this is your boundary, this is your boundary, this is your boundary, let's suppose this is your boundary, this is your boundary, okay. And this system operating on a cycle, okay, cyclic process. This system operating on a cyclic process. And during that, let's suppose at this boundary, let's suppose at this boundary, this Q1 heat will in at a temperature, let's suppose T1. At this boundary, let's suppose Q2 heat will out. At boundary temperature, let's suppose T2. This is the boundary temperature across which the heat will transfer. Let's suppose at this boundary, heat will out Q3. At temperature T3. Let's suppose at this boundary heat will in Q4 at temperature T4, and let's suppose at this boundary heat will out Q5 at a temperature T5. It may be. It may be. So, if we add all the heat transfer, that means what is the cyclic? What does this mean? Integration through a cycle, that means summation. This is what means? This means by the summation. Summation over the boundary. Over the boundary. This indicates that the summation of the summation over the boundary. So, this is our boundary. Now, so if we add, that means this is your positive quantity, you add the system. This is your negative quantity, it will reject. Okay, it is rejecting. This is also rejecting, so this is negative. This is addition, so this is positive. This is your rejection, so this is your negative. Heat. Okay, now you sum of all the things. That means Q1 by T1 minus Q2 by T2 plus minus Q3 by T3 plus Q4 by T4 plus minus Q5 by T5. If you add all these things, and if you add and your result is 0, if you add and your result is 0, then you can say that device will operating in a it is visible operating, one second, device is operating in a reversible manner, okay. So the device will operate in a reversible. If you add this thing and your value is negative, less than 0, if the value is negative less than 0, then you can say that this device will operate in irreversible manner, okay. Now if this is less than 0, how much it is far from 0? How much this quantity far? 0 is the, you may think that 0 is the demarcation line. At the 0, process is irreversible. And below the 0, you are negative, below the 0 there is negative. So higher is the negative value, large is the extent from the reversible. Higher is the negative value, this is the negative value. So higher is the negative value, more extent from the reversible manner. That means higher is the higher negative value, higher is the higher irreversibility. Higher is the higher irreversibility. That means if the more and more extent of the irreversibility, more and more deviated from the 0 in the negative direction, and greater than 0 is not possible. Greater than 0 is not possible. That will say from which theorem? That is called Clausius theorem. This is nothing, this is for the Clausius theorem. That means this is called Clausius theorem. This theorem. This is called Clausius theorem. This is called Clausius theorem, okay. This is called Clausius theorem. This is called Clausius inequality. This is called Clausius inequality. This is called Clausius inequality. And T is the temperature of a system boundary across which heat will transfer. Okay, no problem at all. Now, this is not a temperature of source or sink. It is the temperature across which the heat will transfer. Okay. So, we can say that so this quantity is not equal for the irreversible process. So, which is higher in magnitude, more extent of irreversibility. That means it will large deviation from the reversible process. So, this quantity is measured the extent of irreversibility in a very good manner. Okay, and that is called Clausius inequality. Okay, now that means what is that? D cube cyclic integration dq by t is less than 0. Equal to 0, there is no any problem. Okay, this is called inequality. This is called inequality. So, this is what? This is the temperature of the system boundary. Okay, temperature of the system boundaries across which this dq across which dq heat will transfer. And you can write like that, very important term, T is not temperature of source or sink. This is very important. It is not a temperature of source and sink. Okay, across which, okay, it is not a temperature of source or sink. Clear? Clear, beta? This is clear? Now you can write like this. That means this is cyclic integration. That means for a cycle, so let this cyclic integration dq by t, if we write equality, so what if this is a negative term, if this is your negative, that means what? If the value is minus, that means let's suppose this is your minus some operating value. Let's suppose this is sigma rho. Rho is the parameter which is a negative parameter. That means for the irreversibility, this gives the negative value. Okay. Now, my dear, what is this value? What is this value? If this value, that means rho, very important. If this rho value, this quantity is this quantity is always positive, so that it will negative. If this quantity rho is positive, if rho is positive, that means this is for irreversible cycle. If rho is 0, that means for reversible cycle. This is very important. So positive for irreversible cycle and 0 for reversible cycle. So this rho quantity is a positive. Okay. So this value greater and greater, that means this rho is greater, higher is the higher extent of irreversibility. Higher is the higher extent of irreversibility. If this value, positive value, is greater, the greater. If this rho is more and more positive, if this rho is more and more positive, that means it is more and more extent of irreversibility. More and more extent of irreversibility. So you can write greater the value of rho, you can write like that. What you can write? Greater the value of rho, greater the value of rho, more is the irreversibility. More is the irreversibility. More is the irreversibility. Greater is the greater value of rho, more is the irreversibility. That means if you reduce this rho value, you have to approach the spontaneous process to a reversible process. Okay. Now, so this is all about your cycle. if you think about what is this quantity dq by t, so so here we can say that dq by t, what is dq by t, what is it represent? If we take, this is our system, okay, this is our system. So let's suppose this is our system boundary across which heat will either in or out, no problem, across which heat will transfer, which one? dq, and this dq will transfer at a system boundary temperature T. So this is the representation of this dq by T. Okay, so this is the representation of this dq by T. What the represents the dq by T? dq is the infinitely small heat transfer through a small boundary, and that boundary have a temperature T. Okay. Now, if this system execute in a cycle, so this quantity is either 0 or less than 0, depending upon which cycle the system will execute. Okay. Now, so this is for the cycle. Now, my attempt is that, the question is that, what is this quantity dq by T? That means the quantity dq by T for the process. This is our next thoughts. Okay, I'm searching this questions. Okay, I'm searching this question. Okay, so what is the quantity? This is the quantity. This quantity, see beta, you have one thing very observe. What is that? What is that? That means any quantity x, whose change, any quantity x, this is the quantity and it is equivalent to dq by T. So any quantity whose change is what beta? x2 minus x1. Okay, whose change is x2 minus x1. Now, see my dear, whether this quantity is exact or inexact, that means this quantity is a system property or not, when it is possible. That means if let's suppose if this quantity is a system property, this x quantity is a, let's suppose this is a system properties. If this is your system property, let's suppose if this is your system property, then this is a state variable. State variable. That means what? That means what? Point function. Yes or not? Let's suppose. Okay. Now, if this is a point function, so whose change is exact? Now, if we take a integration through a cycle, so through a cycle, this 1 and 2 point are same, so this is 0. Very important. If this cyclic integration of a quantity is 0, that means that quantity is a property. If a quantity whose change in a cyclic manner is 0, then that quantity is a property. It is right or not? See beta, if we take in an example, let's suppose this is a volume. Volume is a property, and this volume change is what? V2 minus V1. Okay, whose cyclic integration must be 0. That means this volume is a property. This volume is a property. That means in which sense this x of a cyclic integration is 0 in which sense? Reversible sense. Okay, so we can say that the quantity of x of a cyclic integration, it is a 0, and which cycle? Reversible cycle, then that quantity is a system property. That means this quantity x is a system property or not will depend upon the cycle. If this quantity in a cyclic process during a reversible cycle is 0, what is this set? This is the set that now. That means a quantity dq by t, right? This is the quantity, and this quantity is when you do a cyclic integration. This is very important analysis. When you do a cyclic integration of this quantity, whether it is 0, no, it is not necessary. It is less than 0. This have a is equal to 0 or less than 0. Yes or not? Or less than 0. The quantity is equal to 0 during a cycle. That means if this quantity during a cyclic is 0 when there is a reversible cycle. When there is a reversible cycle, that means reversible cycle, this quantity is 0. Okay, so let's suppose this is 1. So this is 1. Okay. Okay. Now, when this quantity during a cyclic process is 0, which cycle is reversible? That means in a reversible manner, very important, I'm telling you, in a reversible manner, this quantity dq by t is a system property. Is a system property. But if the cyclic integration of a dq by t is less than 0 when there is a irreversible cycle, in that manner dq by t is not a system property. That means that means the quantity dq by t is a property or not, that will depends upon the cycle, which cycle the quantity will perform. That means that quantity dq by t during a reversible cycle is zero. In that sense, dq by t is a property, but the cyclic integration dq, same quantity dq by t is less than 0 in a irreversible manner, then that quantity dq by t is not a property. This is very important. Okay, this is very important, I am telling you. That means we can say that the quantity dq by t, this quantity dq by t is a system property, when there is the quantity will perform in a reversible cycle, because in a reversible cycle the cyclic integration of this quantity is equal to 0. That means this quantity is a property or not will depends upon the reversible cycle. But if this quantity is not a system property, is not a system property, that means it is a path function. Different path have a different value. Not a system property, that is a path phenomena, path function. That means different path have a different value. In which sense? When there is a irreversible cycle, why? Because in a Clausius said that during irreversible cycle the cyclic integration of the quantity dq by t is not 0. That means for cyclic integration for the irreversible manner, that means if this is your graph, let's suppose any property y and x is the thermodynamics property. You start from here point 1, you finish here at point 2. Okay, for the any cycle, that means if you, this is the for the cycle, that means this cycle, this will depend irreversible cycle. If the cycle is irreversible, let's suppose this is your irreversible cycle. Okay, this is your irreversible cycle. 1 A 2 B 1. 1 A 2 B 1. This is your irreversible cycle. During this irreversible cycle, this quantity dq by t is not a property. Okay, but for the reversible cycle, if let's suppose this is your y and x, and let's suppose this is 0.1, this is 0.2. So this is a reversible cycle, A and B. So in this sense, this quantity dq by t is a property. So very important, the student will confused here कि sir, I asked many time in the interview that beta, what is this quantity? It is a system property or not? Then the student says that कि sir, yes, we don't know. That means first attempt they can never understand. They cannot able to understand what I am asking. I am asking this quantity dq by t is a property or not? So you can say that yes sir, it is a property. The quantity cyclic integration of dq by t is a property or not? The quantity dq by t is the cyclic integration property or not? When there is a reversible cycle, it is a not property when there is a irreversible cycle. So we cannot say that this is the property. This is a property during the cycle, depends upon the nature of the cycle. Will depends upon the nature of the cycle. What type of the nature of the cycle? That means each and every cycle have a different value. But for the reversible cycle, this quantity is a fixed. That means equal to 0. That means all the cycles have a same value. Okay. Now we come to the next this question. Okay. Now this is the background. This is the background. Okay. This is very important. I'm telling you. Okay. Now the quantity dq by t for the process. What is the process? That is, what is the process for this quantity? Okay. So always keep in mind, this thing is never found in your YouTube channel as this much as a crystal clear. I'm telling you. This is very crystal clear. This is very subtle concept is there. I know you, all of you know that. But once there is someone asks you, you may get confused here. So it gives a very lots of the boost up confidence. Yes, it is clear. It is happening. It is there. It is true. You can discuss with this topic of anyone when you have a lots of the concept like that. Okay. Now, so for the cycle, that means we know that if this is your thermodynamic, let's suppose this is our thermodynamics plane, this is your y and this is your x. Okay. This is your thermodynamics plane y and x. Okay. Let's suppose this is your process 1 at point, this is the state point 1 and state point 1. The system will execute from state point 1 to state point 2, have a different path, and when the path will the different path will combine, they form a cycle. We like that. Okay. So this is the path A. Let's suppose this is the path A. Okay. This is the path A. This is the path B. This is the path B. So this is a cycle, yes or no? This is the path B. Let's suppose there is another path C. Let's suppose there is another path C. So this is the path C. Okay. This is the path C. That means, see my dear, this is the state point 1, this is the state point 2, and the state point 1 to 2 have a 3 process. And these 3 process make a 2 cycle. 1A, 2B, there is a 1 cycle. 1A, 2, 1 to 2 via A plus B, there is a 1 cycle. 1 to 2 via A plus C, there is a 2 cycle. Okay. So, there is a 2 cycle. Yes or not? There is a 2 cycle. What is the 1 cycle? 1 cycle is A plus B and other is A plus C. Yes or not? There is 2 cycle. Okay, there are 2 cycle. Both are reversible. Okay, let's suppose both are reversible cycle. Both are reversible cycle. Okay, one question is come. What that entropy change is a property for a reversible process and not for irreversible. Yes, just now I will discuss. I think Atul, you come join late. This will I already discuss. I think you are late. Okay, so I will repeat again. Entropy change is a property for a reversible process and not for irreversible. Yes, this is okay. This is for that. See, with the Clausius inequality, this all will discuss already. For the Clausius inequality, this quantity cyclic integration of dq by t is less than equal to 0. Okay. Now we know that from the fundamental, forget about all the thing. If there is any quantity whose change, if there is any quantity whose change through a cyclic process is 0, then that quantity is a property. Yes or not? First line it is clear. The first line, see, forget all the thing. Just think basic. If there is any quantity, how to check that quantity is a property or not? So first you think, take any quantity, either property or not, any quantity. Take a change whose cyclic integration is a 0, then that quantity must be a property. Number first. So Clausius inequality dq by t of a cyclic integration is equal to 0 in a reversible manner. That means dq by t in a reversible manner, if you transfer the heat divided by temperature of a system boundary in a reversible manner, in that sense the quantity dq by t is a property. But if Clausius says that if you integrate this quantity over a cycle and that cycle is less than 0, obviously it is not a property. So it is the quantity dq by t is a property or not depends upon the cycle. If the quantity is equal to 0 over the cycle, then that quantity is a property, but this will be when it is done, when it is this reversible cycle. Okay, all these things we have to discuss. Okay, now we'll discuss this quantity dq by t is a system property. dq by t is a system property when there is a reversible cycle. Why? Because cyclic integration is 0. dq by t is not a system property. That means a path function. That means a different path have a different value when there is a irreversible cycle. Why? Cyclic integration dq by less than 0. That means for a cycle, if there is one process is irreversible, throughout the cycle is irreversible. In that sense, this quantity is not a property. But for the reversible cycle, if the this quantity is 0, then that in that sense, this is a property. It is clear? It is clear? Please? It is clear? Now, so there are two cycles, and now my next job is what? My next job is to identify the quantity for the process, not for the cycle. The quantity dq by t for the cycle we know. Okay, what is that? It is 0 or less than 0. More and more less than 0, more and more less than 0, more and more extent of irreversibility. Okay. Now, so for the process, so we take process A, B and C, and these three processes make a 2 reversible cycle. Why? Because why we find the reversible manner? Why? Because we know the reversible is equal to 0. We know the result. Okay. So 2 cycle. So we can apply what is the reversible manner? We know that cyclic integration dq by t for the and mind it beta, for the reversible cycle is equal to 0. We know that. We know that for the reversible cycle this is 0. Okay. So we apply cycle, we apply for A plus B, then we apply A plus C. Okay. So for A plus B, for A plus B cycle, okay? Okay. What is that? Cyclic integration. That means this is for the cycle. So what is the cycle? So we can take this cycle as a summation. So we take 1 to 2. Which process? Process A. And that process, Pratik, yes. dq by t is a property when the entropy value is 0. Right now I am not defining the entropy right now, but you can say that, okay? Right now I am not define any entropy. I am defined only a property, and what is that property? I don't know, okay? But let's take your question, no problem. Yes, Pratik, yes, I understand. dq by t is a property. 1 second. dq by t is a property when the entropy value is 0. Then, but if there is some entropy exists, then it is not a system. No. You don't think like that. First, I will read the question. If the entropy increase, okay, dq by t is a property when the entropy value is 0. Not entropy. Right now, see, beta, I just discuss one by one. We are taking this quantity. Number first, we will come afterward, okay? So, if dq by t is a property, see my dear, dq by t is a property when the, I am not telling the entropy, when the cyclic integration of this quantity is 0. This is clear, okay? If entropy is increased like operation of the liquid to gas, okay, no problem. Then the cooled to the liquid again, then it will be a property. But okay. Second, if not all the gases condense into the, I will take all the question and I will study the question. You just stay with the 5 to 10 minutes, okay? It is clear automatically, okay? It is clear automatically. Your question is very good question. I will discuss when we take a birth of entropy, when we have a birth of entropy, after that this discussion is very useful, okay? First of all, I identify. See, what is the previous classes? Previous classes is only, this is the quantity which is measurable quantity, and that quantity is a measurable quantity. So how it will apply for the cycle, and what is the nature of this quantity when the process cycle is reversible or not, I will discuss up to that right now, okay? Now we take for the process, if this is the, now we have to look at dq by t for the process. Then we defined something. First of all, I have one confusion. We have one confusion. Ki sir, dq by t is a property and dq by is not a property in different cycle. But the cycle is actually composed of infinite number of process. So, what is the value of dq by t during the process? This is our motive. We will discuss. That is the discussion is going on. So, for the process A plus B, 1 to 2, very fast, 1 to 2, dq by t via path A plus 2 to 1 dq by t via path B, and if this is a reversible, sum is 0. Whose gives? This is the Clausius gives, okay? Now, for process B plus A plus C. What is that, beta? Cyclic integration 1 to 2 dq by t for path A, which is reversible, is equal to 2 to 1 cyclic integration dq by t via path C, and this is also 0. Okay, no problem at all. Now, this is a simple logic. Now, if you subtract this one minus, so there is something will cut, okay? This will cut out. This quantity and this quantity are cancelled. Yes or no? This quantity and this quantity. So what is left here? The left here is cyclic integration to, no, not cyclic, process dq by t via path B minus 2 to 1. This is minus dq by t for C is equal to 0. This is equal. Now, that means you see, process 2 to 1 via path B minus process 2 to 1 via path C is equal to 0. That means the quantity dq by t via path A is exactly same as the quantity dq by t via path C. That means this is 0. That means you can say that, sir, 1 second, y and x, 1 and 2, this is the process A, this is the process B, this is the process C. So we can say that the quantity dq by t via path B is equal to the quantity dq by t via path C are same. That is the beauty. That means what that? That means this quantity is fixed. And if we add this one, this is 0. If you add this one, this is 0. So when it is 0? When there is a reversible cycle. That means this quantity dq by t is a path independent. When there is a reversible process. All are the reversible. That means this quantity is independent. This quantity is independent of the path. So it's a system property. System properties is a system properties. That means if you take this quantity dq by t for a process 1 to 2, so this is your, let's suppose, delta x. Why? Because and this x is a property. This x is a system property. Why? Because it is same. This x is the system property. Now, if you cyclic integrate, this is automatically 0. Okay. That means the quantity dq by t for any reversible path is any reversible path A, reversible path C, reversible path B. For any reversible path, this is your system property. This is your system property. Up to this, there is any confusion, please ask me. Up to this, there is any confusion, please ask me. Why? Because this is fundamental. Now we take one by one your question, okay? So, if this quantity dq by t for the path is equal to delta x, that is the system property, and that property is called entropy. That property is called entropy. See, my dear, up to that I am not giving your entropy definition. I only gives the how to entropy change. It is not a definition of entropy. I am telling you literally there are very big confusion here. Ki sir, entropy is, this is the definition. No, it is not a definition. Definition is another thing. it is just change in entropy. What is the change in entropy? What is the entropy? I up to that I will not discuss. I am not discussing here up to that. But मैंने अभी तक discussion इसको नहीं किया. But what is the change in entropy? I will discuss here. That means this is a very important thing is that means for any process, that means this is the entropy. And what is that? This is delta S. Yes or not? Delta S. Or you can write ds. It is not a cut mark, okay? ds, okay? And this is equal to exactly S2 minus S1. Entropy at point 1, S1, or entropy at point 2, S2. Now, my dear, there is one confusion is that, see, very important, change in entropy, like change in property. Change in property, S is the property. Right now, we'll change in property is for any process. For any process. This is very important. That means S2 minus S1 is for any process. That means this is 1, this is 2, you can join any process, either reversible or irreversible. But the S2 minus S1, that change is equal to dq by t only for the reversible. Only for the reversible. So I am repeating here. Delta S is equal to S2 minus S1. That means this is your, let's suppose this is your T and temperature and entropy S. This is a point number 1. This is point number 2. So if this is a point number 1, entropy is fixed S1. If this is a point number 2, entropy is fixed S2. And their change, delta S is equal to S2 minus S1 is fixed for any process. That means from here you can join reversible A, yeah, you can join irreversible B for any process. This is your reversible and this is your irreversible process. That means delta S is equal to S2 minus S1. S2 minus S1 is for any process. Is for any process. What is the any process? Either reversible or irreversible. Either irreversible or reversible. But this delta S is equal to cyclic integration of dq by t only for reversible process. This is very important, I am telling you. Only for reversible process. Only for reversible. This is clear or not? Please, everyone. Right, Pratik. For the graph, can we replace x and y for the liquid and vapor? Yes, bilkul. Liquid and vapor, yes. That means for the graph, can we replace x and y? X and y, you can replace, okay? For liquid and vapor, yes. Can we replace like that? Okay. What are you telling? This is your, let's suppose, y and x. Liquid and vapor. Okay, no problem. Just now, this is your vapor dome. For the graph, can we replace x and y for the liquid and vapor? This is your liquid and this is vapor. Okay, what do you think? What are you asking? And can the triple point of the water graph valid for this and triple point? Triple point. Triple point is in this graph. In this graph there is a line. There is a line. And can the triple point for the graph? In this graph there is a line. Okay, it is not a point. And can the triple point of the water graph valid for this, and x and y would be temperature and pressure? Yes, of course, no problem. Where is the problem? No problem. This is right. It is right, but it is not related to entropy content. Temperature. This is a PT diagram. Pressure and temperature, not temperature and pressure. Pressure and temperature. Okay? If S2, if S2 and S1 is 0, if S2 and S1 is 0 at this point, if this is a T and S diagram, at this point it is 0. That is called critical point, not a triple point. It is a critical point. 0 in the graph with line 1 or 2 won't exist, mean the more area under the curve, more entropy. No. See, my dear. See. Okay. This is your temperature and this is your entropy. Okay. This is your vapor dome. This is your vapor dome, and these are not a triple. This is a critical point. This is a critical point, and what is the critical point? This is a critical point. Okay, this is a TS diagram. If this is a PV diagram, the critical point, temperature point. Now, in this, at this point, S2 minus S1. At this point, S2 minus S1 is 0. S2 minus S1 is 0. That means change in entropy is 0. That means entropy is there, but the change is 0. That means S1 is there and S2 is there, right? Okay. 0 in this graph with line 1 to 2, or not 1 to 2. Where is the 1 to 2? Where is the 1 to 2? One to two, I think this line is, yes, it is not exist. Means the more, 1 to 2 not exist, means the more area under the curve, more is the entropy. See beta, TS, yes, it is another thing. I am taking this one. If this is 0. So at this point, the entropy change is 0. Sir, the other graph, this one, yeah, this one. First, discussion. First idea, this graph, yes or not? Please tell me, this graph or not? Then we'll show another graph. You will talk this graph or not, Pratik? Are you talking about this graph? If S2 minus S1 is 0, no, okay. So this graph, you are talking about this graph? No, okay. You are talking about this graph? Or this graph? Yes, okay. You are talking about. Now, see my dear, see if in this graph S2 minus S1 is 0. S2 minus S1 0, that means entropy is constant. If you are talking about, sir, S2 minus S1 is 0. Okay. That one, na? That one, Pratik? I think you are discussing with this one. This graph? Upper right. Okay, this graph. Okay, no problem. This graph. This is the very disadvantage of online classes. Upper right. This one? Now I am understand what you are asking. This graph? See, my dear, yes or not, please tell me, then I will discuss. What are you are asking, I will discuss you. Okay, no problem at all. Up to this is clear? Up to this is clear, beta? Theoretical part is clear? Okay, now, take this one. Take this one. Okay. I am happy to ask of your question, okay? This is your T, let's suppose this is T and S, okay? This is point number 1, this is point number 2, this is for the reversible path A. Let's suppose this is an irreversible path B. Okay, now what's your question? Just write down again your question. What is that? Is upper side. One second, I've just shown your question. Your question is your question is Pratik, yes or not? This is your question. Ki sir, F1, if S2 minus S1 is 0 in that graph, that means this is your S1, this is your S2, okay. Okay. If S1 minus S2 is 0, that means you can say that this is S1 minus S2 0. Okay, no problem. With line A to B, one second, just S1 minus S2 is 0 with the graph with line 1 to 2. What exists means the more and more. No. Yes, my dear. Yes. See, what is mean by this one? What is mean by that? Entropy will exist, but that entropy is the absolute entropy. That means, beta, if S2 minus S1, this delta S is 0, that means this graph, that means what is the process? This is for the process. The process delta S is equal to, this is defined for 1 to 2 via path A dq by t is equal to 1 to 2 via path B dq by t. It is right or wrong? Please tell me. Though this is irreversible, B is irreversible, but this value is the same for this one or not? Matlab, this is for reversible and this is for irreversible. And both gives the same result. Yes or not? S2 minus S1. Okay? But if you define this dq by t, this is our change in entropy. Once you define the change in entropy, that change in entropy is valid for both reversible or irreversible. See, the entropy is defined dq by t is for reversible manner. Once it is defined, it is applicable for both process. See the beauty. That means the change in entropy is 0. The change in entropy is 0. That means S2 minus S1 is 0. The change in entropy is 0. That means what? This is what? The process 1 to 2, this S2 minus S1 is 0. Not a cyclic. This is a process. This is a if you do a cyclic integration, that means if you see ds is equal to S2 minus S1. And if this is a cyclic integration, it must be 0. Then that is the property. But the cyclic integration, this ds is not 0, is not equal to 0. Then this S is not a property. In that case, there is a generation concept is there. That means if delta S is cyclic integration of dq by t. This is for irreversible. There must be add some positive quantity, not an S generation. We'll discuss. We'll discuss this one. Obviously. More, yes, no, it is not like that. More area, reversible manner, you can say that. Reversible manner, the change in entropy is defined. What is that? dq by t. See, this ds is equal to dq by t, and this dq is equal to t ds. So area is you defined only for reversible, not for the irreversible manner. Why? Because in the irreversible you cannot. This is for the reversible equation. More and more area under the represents more entropy, but I got answer that even the entropy exists in the graph, difference in the entropy S2. Graph is showing different. So it is for the reversible manner, beta. Yes, it is defined. This is defined, but you cannot define for the path B. Why? Because this is not defined. But if you find the entropy change, once you find for the reversible manner, once you get that entropy is also applicable for the irreversible manner. That is the important thing. That means if you find the entropy for the actually irreversible manner, you must have a generation. And that generation will depend upon the path. So this is the property, but this is the path function. And this generation is higher and higher for the higher and higher irreversibility. Higher the irreversibility, higher is the value. That means this is measure the extent of irreversibility. But this is the property. This is always property. Either this is 0 or either this is not a 0. This is always property. And that property is a 0 or not, that will depends upon the my dear, if generation is 0 and there is no heat transfer, that means reversible adiabatic process, and reversible adiabatic process must be isentropic. See the beauty. If the generation is 0, that means there is no any irreversibility in the system. There is no any irreversibility in the system. Generation is 0. And there is no any heat transfer. So this is the isentropic process. This is for the process, not for the cycle. This is for the process. Now, if the generation is there, and there is a heat transfer is also, but it is not, it is 0 also. So it may not be the isentropic is a reversible adiabatic, but this is 0 for adiabatic, this is 0 for reversible. So reversible adiabatic must be isentropic, but isentropic need not be reversible and adiabatic. Why? Because let's suppose this is minus 20 and this is a plus 20. So this is 0 ultimately, but this is not a reversible adiabatic process. This is an irreversible non-adiabatic process. So isentropic will 0 or not. Isentropic will 0 in both manner. Reversible adiabatic or irreversible non-adiabatic. There is a magnitude. So if you say that, see my dear, if you stir the system, I am asking you, there is any situation that you are stirring the system, but the system is cooled. Yes. Yes. See, if you stir the system, entropy will increase. That means generation will increase. This is irreversible. That means this is not 0. But you struck the heat more than this one. So there is a cooling. Final entropy will reduce. That means you stir the system, generation is there, irreversibility is there. Now, when you stir the system, you extract more and more heat. So this is a minus, negative is more. So there must be less entropy will decrease. So system entropy may be increase, may be decrease or remains constant. But at a local, but global, at a globally, the system entropy, that means a system, that means universe, a isolated system, always increase. These are the concept. I hope this is clear to you. Pratik, I hope it is clear to you. Yes or not? Please tell me. So we'll discuss later on this topic, no problem. Okay. So area will represent or not, it will depends upon the, if this is S2 minus S1 is 0, we cannot say that the process is vanishes. Okay. So and at a critical point, what is the critical point? If you draw the PV diagram, I will tell you by your interest, mind it beta. I will show you. This is the critical point. This is saturation vapor, and that is the temperature line, constant temperature line at a critical point. And that constant point at the critical point is what? Is what beta? This is what? Maximum, minimum, this temperature? No, it is a, what is called, that is called, one is the, there is a, that means double differentiation must be 0 and single differentiation must be 0. It is not a maximum minimum point for this point, but for this graph it is minimum. That means this is at this point, this is an inflection point. This is your inflection point. Inflection point. So inflection point must be dou square P by dou V square is equal to 0. But by default here, dou P by dou V also be 0. But this dou P by dou V with respect to this graph. So inflection point, it is not a maximum point, but at this point, this is an inflection point. And if you represent the TS diagram for this one, so TS diagram, if you represent the temperature, that on the TS diagram, what is the pressure diagram? What is the pressure diagram on the TS diagram? This is T and S. What is the pressure diagram? This is your pressure diagram. This is your pressure diagram. This is your pressure diagram, and there is a temperature diagram. So on the TS diagram, this is your SG, SF, and this is your SG, and SG minus SF at a point is 0. So SG minus SF at the point is 0. That means entropy is fixed. Yes. Yes, it is fixed. Why? Because triple point, the degree of freedom is 0. The degree of freedom is 0. That means what? All the properties are fixed at that point. No any other extensive property or intensive we can require to define the state. That means this critical point is a fixed point, no need to define. Why? Because this is a critical point, entropy is defined, and that is a fixed value. So critical point is a point where the degree of freedom is 0, equilibrium point. This is the equilibrium point. And that equilibrium point on a PV diagram of a temperature axis is a point of inflection point. That is very important, I am telling you. Okay, so why the entropy is same? Why? Because this point is a equilibrium point. This is a equilibrium point. Critical point is a equilibrium point. This is your equilibrium point. And equilibrium point, all the properties fixed. Why? Because degree of freedom is 0. That means there is no any property is required to define this point, so that entropy is same at each and every situation. It is clear? It is clear, everyone? Please reply in the chat box. We'll discuss this thing in very detail, but in our classes, in regular classes, we'll discuss all the things. With the YouTube channel has a very less time we have. So we'll cover all the things where the student facing the difficulty. What is my view? My view is the cancer, treatment of the cancer. What is the cancer? You have a confusion, many confusion during the study, and that will treat that. That means we have to eliminate, you have to reduce that difficulty level. So for that purpose, we have to go little bit fast for that one, but that where the point is very clear for the student community, and there is a sometimes there have a big confusion created in the mind by the student. Why? Because when we are asking frequently, I ask frequently question, there have a confusion, much more confusion. Okay, so up to that we end up here. We'll meet in the next session. Thank you. Bye bye.